All right, so today's lesson is going to be on quadratic inequalities. It's pretty easy. It's pretty much based on can you factor for the first couple, and then we're actually going to graph them on an xy instead of on a number line. So here's our first one. X squared plus 2x minus 8. Right? What we're going to do is we're going to factor that. 1 times 1 is 8. That subtracts to be 2. Right? So we have 4 and 2, positive, negative. Think of them as roots. Just find the root. So we get x is negative 4, x is 2. We're going to put them on a number line. Negative 4, 2. Now let's just talk about the inequality. Once you see that, you know there's more than one answer that's going to work. So just give you a quick little intro. Great or, right? I know how to spell great or. Oars of a boat, right? So if we have our boat, we have our oar locks. We're going to go out from the boat. Great oars go out. Less than are going to go in. If it's equal to, these circles are going to be solid. If it's not equal, just greater than or less than, they're going to be open. So, great or, going back to here, great or out. Change colors. So all of these answers are going to work. So if we want to write it as an integral notation, so I'm going to go negative infinity to negative 4, bracket, parenthesis, or 2, bracket, infinity. Remember, brackets, the number is included, parenthesis, the number is not included. So that's the first one. That's how easy it is. Graph the parabola, or sorry, factor the parabola, find your roots, plot your roots. Great ors go out, less than's go in, circles, equal to, if they're equal to, they're solid. If they're not, they're open. Try another one. X squared minus 25 is greater than 0. So again, I automatically know great ors, they're going to go out. I factor this. X plus 5, x minus 5. I tee it up, negative 5 and 5. Draw a number line. Negative 5, 5. Go back to here. Great ors, I'm going out. No equal to. So those are my answers. All right? So that's graphically your answer. If I want an integral notation, negative infinity to negative 5, parenthesis, parenthesis, right? Or 5, ooh, that's a parenthesis, 5 to infinity. That's how easy it is, on a number line. Right? For those checkers out here, you can pick numbers. Left of negative 5, in between 5 and negative 5, to the right of negative 5. You'll notice it will work here, here, but it won't work there. Please never check the roots. Don't check these numbers. Check ones in between it. So that's pretty much on a number line. Great ors we shade out, less thans we shade in. All right? Let's try another one, a little harder one. Oh, let's remember a trick you learned back in middle school. If you ever multiply or divide by a negative when you're dealing with radicals, you must flip the inequality. I don't like factoring if it has a common term, so let's pull out, well, let's divide everything by a negative 1. So I have 2x squared minus 20 plus 20x plus 32. Let's flip that around. It would have eventually happened anyway. Now I'm going to pull out a 2. So I get x squared plus 10x plus, what's that, 16 less than or equal to. Let's see if we can factor that. Do we have factors of 16 that add to be 10? Yes, we do. X plus 8, x plus 2. Tee it up. So we get x is negative 8 and x is negative 2. Draw my number line. So I put one at negative 8, put a circle at negative 2. I'm going to go less than in between them. Let me switch colors. They're all equal to, color them in. This 2 right there drops out. It does not have a variable. That answer in integral notation is from negative 8, bracket, negative 2, bracket. Again, for you checkers, checker number left of 8, in between them, to the right of them. You should know it should only work in between. It's that easy. Great ors out, less than's in. All right, let's graph them. So y is greater than x squared minus 1. So I already have it here in my calculator. So I'm going to go second graph and go to my table and write down that table. Again, that's the work for this. So let's just write down that table. The turning point is 0, -1, -1, 0, -2, 3, -3, 8. 0, 3, 8. So let's graph it. 0, -1, -1, 0, there. 2, 3, 8. Okay, now when we graph it, you got it. There's some things we need to remember. If it's not greater than or equal to or less than or equal to, it's going to be a dotted parabola. Right? And then great or, we're going to shade above. Okay, so I'm going to draw a dotted parabola. More. All right, and I know it's going to be shaded inside, but here's the best thing. Pick a point. Probably check 0, 0. If it works, that's where you shade. If it doesn't work, then we shade outside that. So let's try 0, 0. Is 0 less than 0 squared minus 1? Greater than. Is 0 greater than -1? Yes, that works. That's where we shade. It's that easy. Again, you need to show me that table that we put there. All right, and the last one. Right? Y is less than x squared minus 4x plus 5, minus 5, sorry. So go to your calculator, plug it in. I got this, -1, 0, 0, -5, 1, -8, 2, -9, 3, -8, 4, -5, 5, 0. All right, things I know. It's going to be a dotted parabola. Less than. I'm going to shade below. Okay, let's graph it. So -1, 0, 0, -5, -8, -9, -8, -5, 0. It was a dotted parabola because it was just less than. And then watch what happens. We check 0, 0. Is 0 less than 0 squared minus 4 times 0 minus 5? 0, 0. So is 0 less than -5? No. So our answer is everything outside this parabola. Dotted parabola, shade out. All right, you have 5, 6 questions for homework I'd like you to try. Thank you. See you Monday.